Hello wonderful person, this is Anton, and today we're going to be discussing this discovery coming from the galaxy you see right here of what seems to be two supermassive black holes on a collision course. But they seem to set a new record for the closest two supermassive black holes and the ones with the smallest separation between them. Which is actually a discovery that can potentially help us solve a lot of problems. A lot of problems with how these massive black holes are created, and problems trying to figure out how certain unusual galaxies are formed as well. And this is actually what I wanted to start this video with. I wanted to briefly talk about the catalog known as ARP catalog, also known as the Atlas of Peculiar Galaxies, released by this wonderful person, Halton ARP, back in 1966. And just like the name implies, it's a catalog of unusual and somewhat strange galaxies. Galaxies that don't really look like your typical spiral galaxies, the typical elliptical galaxies, or even the typical irregular galaxies. Galaxies that sometimes contain something strange and somewhat unexplained on the inside, or at least something that's difficult to explain. Though in most cases, it's usually something to do with the galactic collisions and galactic interactions. Here's a good example. This is the 147th object in the ARP catalog. And it seems to be some sort of an interacting pair of ring galaxies. But whatever is happening here is of course anyone's guess. But there are some really interesting entries in the ARP catalog that are just kind of difficult to explain. Some galaxies have, for example, very unusual galactic arms, or some other unusual structures that even through collisions are difficult to explain. And one such example is this galaxy known as NGC 7727. The galaxy located roughly around 89 million light years away from planet Earth. And even though this is technically a spiral galaxy, it seems to contain several plumes and several irregular shapes on the inside to basically qualify it as a peculiar galaxy. A galaxy that's in this atlas as number 222. And one of the main reasons it's in the catalog is because of its unusual spiral arms. They're basically amorphous, they don't really have a very defined shape. Which does become kind of obvious if you look at the actual image. Now the outlines of the arms are sort of visible, but these shapes themselves are not clearly defined. And because of this, it's always been assumed that all of this was formed approximately 1 billion years ago from some sort of a massive galactic collision, which is basically the explanation for most of these peculiar galaxies. And it does become slightly more clear if you look at this picture. Notice how these arms sort of seem to stretch all over the place as if something spaghettified them, which often is a sign of a galactic interaction and potentially some sort of a collision. Which also means that at least one of these galaxies was probably a spiral galaxy, and very likely both of them were, eventually mixing and forming what we see here. And it's always been believed that this probably happened approximately 1 billion years ago, and in the next few billions of years, this galaxy is going to become somewhat more elliptical in shape and will very likely have no arms left whatsoever. But it's really this recent discovery that definitively proves that this is a result of a galactic collision. And it's something to do with the unusual formation in the center of this galaxy. You can actually even see it in this picture. There are two star-like objects right in the center of the galaxy itself. With all of this becoming a lot more clear once you start zooming in. And as you have probably guessed by now, both of these seem to be supermassive black holes. They seem to be centers of ancient galaxies. Or basically each of these star-like objects is an ancient galactic core, although one of them is a lot more massive than the other, suggesting that this particular initial galaxy was also a lot more massive. Moreover, these two objects are slowly spiraling toward one another, suggesting of course that they're going to collide sometime in the future. Although the current distance between these objects is still quite far away, it's about 1600 light years, which is roughly the same distance from planet Earth to the Orion Nebula. Nevertheless, at the moment, these are basically record holders, the closest supermassive black holes, both in distance away from one another and also to planet Earth. The previous record holder was roughly around 500 million light years away from us, and those two black holes were much farther apart as well. Which makes this a pretty exciting discovery, and potentially a discovery that can help us solve a lot of mysteries. Or at least mysteries when it comes to figuring out how these massive black holes form to begin with. And the biggest mystery here is what's known as the final parsec problem. And it's more of a problem with not understanding how black holes that are massive enough can come closer to one another in order to combine. Now, there are more details in one of the older videos, but in essence, we know that really massive black holes, like the ones in this particular galaxy, can sort of come closer and closer to one another because of the interaction with a lot of other matter, a lot of gas, a lot of various stars, that will slowly decrease the orbital speed of these black holes, making them come closer and closer to one another. The problem is that at some point, within approximately 3 to 4 light years away from one another, they will no longer have enough mass or enough stars between them to make them move even closer. In other words, they'll be far enough that there is no gas between them to slow them down, but they'll be far enough from each other where gravitational waves unfortunately don't have much influence just yet. And so in theory, and here we're talking about mathematical/physical theory, this is where two massive black holes should technically get stuck and will probably remain for trillions of years, not even billions of years, most likely unable to collide with one another. Now, because of this problem, for many years now, the scientists have been trying to find an example somewhere or some sort of a unusual galaxy where black holes might be a little bit closer, maybe 1 light year away from one another, or maybe even closer. And at the moment, there is only one potential example, and even that one is not entirely certain. The galaxy with the name that you see right here shows signs of some sort of an unusual pattern that seems to occur every 1800 days. And because of this, some of the scientists suggested that maybe it's because of the supermassive black hole pair right at its center. But there are a lot of other explanations. For example, it could be because of certain shapes inside the accretion disk itself that create this unusual pattern. For example, maybe it's caused by some sort of a massive object that sort of warped the disk itself. And it doesn't have to be a black hole. Because of this, it's still uncertain how supermassive black holes combine and how they form more massive black holes. And that's the final parsec problem in a nutshell. Unfortunately, because of the distance between these two black holes, this doesn't really help us solve this problem just yet, but it's helping us get closer. But it does help us get a little bit closer to answering this question. But anyway, what else do we know about these two objects, and what exactly did the scientists recently discover? Well, first of all, this is, as I mentioned before, not really that close, 89 million light years away from us, which is almost double the distance to the famous M87 black hole. This here was approximately 55 million light years away. But one of the more interesting discoveries is really in regards to the masses of these black holes. As you can see here, the smaller black hole is about 6.3 million solar masses, and the bigger one is 154 million. This of course means that both of these black holes are significantly larger than the one in the middle of the Milky Way galaxy. And based on current calculations, in theory, they should be colliding sometime in the next 250 million years, eventually forming something roughly around 160 million masses of the Sun. But in terms of the actual science, at least for the astronomers, it's really the way that this was discovered that's really exciting. Which is also why it took so long to discover this. In order to discover these black holes, the scientists didn't really look at the interactions with the accretion disk, or any kind of X-ray emissions or any other really powerful light. They really looked at the stars orbiting the tiny region of space 89 million light years away from us. Or in other words, they focused on what's known as the dispersion velocity of a lot of different stars in the vicinity and tried to average out and calculate what could be possibly causing their velocities in the way that we were observing. And they did so by measuring the spectral lines, which you kind of see in this simulation as well, and trying to calculate the mass of the object by looking at the width, the total width, of each of the spectral lines produced by the central object. And based on the width of these spectral lines, you can then, in theory, determine the total mass of the object in the center. And that's exactly what they did. By measuring the width of these tiny lines here and also here, they were able to then measure the velocity of stars in the vicinity, which then allowed them to calculate the total mass of the central object. And because there's really nothing else to give away the presence of these black holes, it's really the velocity of the stars nearby that sort of made it possible. For example, some of the stars near the larger black hole here move at ridiculous speeds of hundreds and even thousands of kilometers per second. And theoretically, there's nothing else except for a black hole or really massive black hole that can make them move so fast. And all of this was of course possible because of the new instrumentations in the European Southern Observatory and a lot of new techniques that scientists have developed in the last few years. Which also means that we're probably going to be discovering more of these unusual objects in a lot of other galaxies that are peculiar in some way or another. And possibly some other galaxies where black holes have been sort of suspected for a very long time, but have never been officially proven. And so only future will tell what we'll find using these techniques and using these new instruments. But for now, this is definitely a really exciting discovery and a really interesting opportunity to study supermassive black hole pairs. Something that we'll probably discuss in some of the future videos as well. But until then, check out all of the relevant links in the description below. Thank you for watching, subscribe if you still haven't, and share this with someone who loves learning about space and sciences. Maybe come back tomorrow, maybe support this channel on Patreon by joining the channel membership or by buying the Wonderful Person t-shirt you can find in the description, and either way, stay wonderful, I'll see you tomorrow, and as always, bye bye.